Hi guys, and welcome back to our first lesson on complex numbers. Complex numbers from paper number 1. Now I'm going to get you to start off on page 172. Page 172 should look like this. Going to get you to jump over as far as there, and we're going to get started. Now we're going to start off by discussing what a complex number is, and then we're going to jump into number 1, as you'll see here, imaginary parts, doing exercise 1.1 in this lesson. So guys, to get started, what a complex number is. Now, complex numbers is a question that appears on the Leaving Cert exam every single year as a standalone question on paper 1. Now, by standalone question 1 to 6 is what I usually refer to as the standalone or short questions, where basically you'll only have it based on a topic like complex numbers. And unlike your question 7, 8, 9, and potentially 10, depending on what year you're doing the Leaving Cert in, you won't have that kind of mix of maybe functions and calculus and algebra and, series and sequences all in one question. So complex numbers is a lovely question, and we typically see one question based on it. Now, what is a complex number? A complex number is a number that takes this form, the form a plus bi. Apologies, struggle there. Now, here to start off with, both A and B are elements of OR. And what do we mean by OR? OR represents a real number. And a real number is any number on the number line. So positive or negative, whole numbers or decimals. So there's two parts here. You're going to see A at the front and BI down the end. A up here represents my real part. My real part or my real number, whichever you want to refer to it to. And down here, my B or my BI represents what we refer to as an imaginary part. And the I is a special part there. Now, a complex number could be something like 2 plus 3i or 7 minus 9i. They're all complex numbers. But in this lesson, we only want to focus on one thing. Our imaginary parts and where they actually came from. Now, imaginary parts you're going to see here on page 172. On page 172, you're going to write down one thing beside the words imaginary parts, the letter I, because I represents our imaginary parts. Now, as mentioned, complex numbers have imaginary parts I, as there's no real squared as a product of a negative number. So where have these imaginary parts come from? Well, take a look at this. If I say to you 2, and I ask you to square 2, you'd say to me 2 squared is going to be 4. And then I might say to you, well, what's the inverse of square? You tell me square root. So then I'd say, well, get 4 back to 2. So I get the square root of 4, and it would bring me back to 2. Basically, square and square root were the inverse of each other. However, what about if I give you a negative number? For instance, I say now minus 2, and I ask you to square it. Now, when you square a negative number, any negative number to an even power, as you might remember, will give you a positive number. So minus 2 to be squared is minus 2 by minus 2. Minus by minus is a plus. 2 times 2 is 4. So that gives me 4. Now, if you're using your calculator, make sure you use those brackets. But minus 2 to be squared is 4. But then if I try to get the inverse of that square, and I say to you the square root of 4, it brings you back to 2. So actually here there's a discrepancy. Now, this is the reason imaginary parts were invented by mathematicians. Basically, what they said was that I squared is going to equal to minus 1, and I is equal to the square root of minus 1. Now, this is typically given to you in your exam question. However, you'll normally only get the top part here, I squared is equal to minus 1. However, just to point out what we're looking at here, if I tell you I squared is equal to minus 1, and I want to get I on its own, what's the opposite to square? Well, you tell me the square root. If I get the square root of the left-hand side, I do the same to the right-hand side. So on the left-hand side here, square and square root are going to cancel. So I is equal to the square root of minus 1. So typically the first part, I squared is equal to minus 1, is what's given to you. Now, we're going to jump straight into this and we're going to go across to exercise 1.1. There's nothing here that isn't given to you on your exam. And on exercise 1.1, we're going to be learning how to find the square root of a negative number. Well, not really. We're going to look at forming imaginary parts across the page over on page 173. So here, with exercise 1.1, we're basically trying to take these negative square roots and we want to convert them into an imaginary part. I'm going to be writing down IM and just the word part beside it for imaginary part. We want to place them in the form, as you'll see there, KI. Now, if you pick up your calculator and you say to yourself the square root of minus 16, it's just going to come up error. So we want to take these numbers and we want to form them into imaginary parts with what we know. Now, what do we know? We know that I squared is equal to minus 1 and the square root of minus 1 is I. So let's take a look. Now, first of all, here we're given the square root of minus 16. The square root of minus 16 to me is the exact same as me saying the square root of 16 times minus 1. That dot there meaning times. 16 times minus 1 would give me minus 16. Which technically means that this is the exact same here as me saying the square root of 16 times the square root of minus 1. Now we know the square root of 16 is 4, and the square root of minus 1, as you'll see here, is I. So what we've now done is we've converted this negative square root into an imaginary part. Let's look at the second part here, part B. Here we have the square root of minus 25, which is the same as we said before as me saying the square root of 25 times minus 1, which is the same as saying the square root of 25 times the square root of minus 1. The square root of 25 is going to leave me with 5, and the square root of minus 1, as we know from here, is going to leave me with I. So we've made this negative square root into an imaginary part. Next one, part C, the square root of minus 49. The square root of minus 49 is the same as me saying 49 times the square root of minus 1, which is the same as saying the square root of 49, as I actually said previously, times the square root of minus 1. The square root of 49 is 7, our calculator will tell us that, and the square root of minus 1, as we know, is I. Again, we've converted this negative square root into an imaginary part. Next, we have part D. Part D, the square root of minus 100, which is the same as me saying the square root of 100 times minus 1, which is the same as saying the square root of 100 times the square root of minus 1. Here, the square root of 100 is 10, and the square root of minus 1 is I. That there, my imaginary part. The last part here, part E. Similar idea here. We have the square root of minus 121, which is the square root of 121 times minus 1, which is the same as saying the square root of 121 times the square root of minus 1. The square root of 121 is 11, and the square root of minus 1 is I. Now guys, while this isn't something that we see on its own, where we convert a negative square root into an imaginary part, it is something that we'll see when we actually use the minus b formula or the quadratic formula in complex numbers. So it's nice to get started on where these imaginary parts actually come from. In our next lesson, we're going to look at complex numbers, our real and imaginary parts together.